I'll be starting off with my session. Okay. So in the previous session, we have just started with some of the machine learning topics, and now let's get started with our important. Let's have an important discussion here. So shall we get started with our today's session now? I think most of you are already done with sending the mail IDs. Okay. So I'm starting with our another algorithm. I'll be starting with my next algorithm. In the next algorithm, we'll be talking about k nearest neighbors, KNN, and then there will be one more algorithm which will be for unsupervised learning. K nearest neighbor is one of the easiest one and one of the weakest at the same time. Let's try to understand it, how k nearest supervised learning algorithm works. Let me share you the screen and let's begin our proceedings. So in here you can see the k nearest neighbors algorithm. In supervised learning model, k nearest neighbors, the KNN is one of the simplest machine learning algorithm and one of the weakest one as well. If you will compare with other rest of the algorithms, this is more simple as it does not include any parametric approach. It is a non-parametric algorithm. That means it will be not using any probability part or something like that, or probability distribution does not include that in order to apply supervised learning algorithm. KNN is one of the simplest machine learning algorithm used for both classification as well as regression problem statements. I'll use my whiteboard. K nearest neighbor, you can call it as KNN. Okay, let's try to take this example here. So we are having some features here in this case. You can see those features are given by education years and professional training, which will be represented by yes or no, as you can see in it here. So on the basis of them, we will try to perform our classification part. So let's try to understand it deeply here. K nearest neighbors is our next target. The working of k nearest neighbor is pretty straightforward. What we do here is we try to okay, so few points about here. It is a supervised learning algorithm. It is a supervised learning algorithm. With a known target, label or column. It is non-parametric, as it does not make any assumption about the data. About the data distribution pattern. It is called as one of the laziest algorithm. I'll prove it why it is called as lazy, because it takes a lot of time in order to actually classify your data. In order to classify, actually, it takes a lot of time. If your number of samples will be large in this, it will take a lot of time to compute. K nearest or KNN uses feature similarity to predict grouping or clustering on the basis of this similarity. On the basis of grouping or similarity. Let's take some steps here. Let's take the steps. Find the nearest neighbors. First of all, we'll be taking up the nearest neighbors. For a new unidentified sample data. Here calculate distance between new sample data and each training each training points. Let's take about here. These are all my sample data. Represented by X, represented by Y. Let us take here my samples 1 and 2. These are all my two samples. x1, y1, and x2, y2. Fine. For example, you can think of this as our data for two classes are there. All right. Maybe I can take here this as two features. So for example, on one side we have got body mass index. On the other side we have got what you can say age. On these two bases, we are gonna classify the sample as if a person is having diabetes, if a person is not having a diabetes. On one side we have got class 0, the other side we have got class 1. Now let's take my sample data. This is my two sample here. These are all my two samples. What are we trying to do here is we are trying to computing nearest neighbors. We can easily use here Euclidean distance formula. That is the formula we have to use to find out the distances between this new sample. If it is closer to the sample for class 1 or the sample that belongs to class 0. So we'll try to compare the distances. If this new sample belongs to it becomes closer to the class 0, then we'll say that it belongs to class 0 value. This will be predicted as class 0. And if it is closer to the class 1, then we'll say that this new sample is nothing but it is classified as class 1. As simple as that. So the point is only one thing, that you take the data, okay, and then you just check the distances. That's it. And with the help of this, we are trying to find out the nearest to the new sample decides if it is nearest to class 0 or class 1. Fine. So as simple as that. It has got just one simple thing. We find the distances between the samples and then we choose which one is nearest. In order to and what is the basis of finding whether it is nearest or not? Simple, x1 minus x2 square and y1 minus y2 square, and we take the under root of it. This is a formula which is used to calculate the distances. Let us try to understand a few of the issues which we can find out here with one sample. There could be a great possibility that if we are just choosing it with the help of one sample, then there could be equidistance part, right? There could be a great chance that in terms of k and n, they both are equidistant. Step number 2. So if we will look at here, x value, y value, and let's take the samples here. These are all my samples here. These are all my samples. Next. And let's pick my sample here. Okay, suppose this is my new sample. Now the question arises, how does we will choose that whether it belongs to class 0 or class 1? Suppose it is placed here. Okay, it is placed here. Now I have placed my value in such a way that these both values are having equidistance. Then obviously it could be predicted. Definitely it will be predicted, but it will be predicted in such a way that I'll be having I mean, I'll be not sure if this classification will be true or not. So maybe there could be a misclassification here, right? There could be a great chance that might be misclassified. Whereas you can see that the nearest other samples to this particular class is straightforward, presenting that this particular black point is very much closer to a large density, a large cluster of class 0 value. Correct? Now let's particularly take a round off. So here is my sample distribution. Suppose I have taken here k equals to 5. This is my circle for k equals to 5. What is the meaning of k equals to 5? K here is the number of nearest neighbors. You can also take a k equals to 3 here. Let's say this is for k equals to 3 here. This is for k equals to 3. This is for k equals to 3. You can say that we are taking up here in this case only the 3 nearest samples. We are taking here 3 nearest samples. So on one side we have got k equals to 5. On the other side we have got k equals to 3. Fine. So this is one of those algorithms where the difficulty is in choosing the number of neighbors, choosing the nearest neighbors for k data points. And which will be selected? Based on distance. Based on distance formula. So first of all, what we do is we actually calculate the distances between all these different values, and then we choose which one is nearest. Then we choose here which one is nearest to this particular value. Which one is nearest? Which one is nearest? Okay. And on the basis of that, then we will choose which one is up in the region of k equals to 3, in the region of k equals to 5, in the region of k equals to 15. Okay. This part is clear. So very simple it is. We are trying the next part. We have to understand that in this case, we have to look for how many number of nearest neighbors which are available to us. So this is the difficult part. Let's try to understand what happens in this case is that in ideal scenario, the k value, it is when equals to under root of number of samples. That is under root of n. This is we choose in ideal scenario. There is no endless point. I mean, this is if more will be the data point, the more stronger your k nearest will be, and the more lazy it will be at the same time. So drawback is this one only. This is the drawback. But you can see that this is a non-parametric approach, so you have all these dependencies on how many number of nearest samples you are taking. So drawback is if chosen k will be a little high value, then algorithm will be slower. Then algorithm will be trained slower. Okay, got it. That's what the drawback is, and on the basis of that, we will be trying to classify our data on the basis of class 0, on the basis of class 1. Clear? So that's it. The algorithm is super simple to understand it. Let us try to, okay, now there is one more trick that we will be discussing as we will progress ahead. That the best way to choose your number of number of k nearest neighbor is using grid search CB. So question is choosing ideal value of k can be tricky. Solution, grid search CV. This helps in calculating, this helps in choosing the parametric values, calculating the parametric values. No, in this case, cosine similarity will be not used. Cosine similarity is used in your recommendation engines. Here there is no need for that. Euclidean distance formula is more than enough for that. Or Manhattan distance formula you can take, which will be modulus part. So ultimately we choose only the distance formula. So these two are used. Either Euclidean distance formula is more than enough. Cosine similarity is cosine is used majorly with our recommendation engines. Okay, let's get started with our next part. Somebody was asking about outliers effect on KNN. So see, the point is like in this case we are trying to choose the nearest samples. So outliers is anyhow will be rejected here, correct? Outliers will be what? The data which are away from this entire cluster of your samples. So outliers effect on KNN, correct? That is what you are trying to understand. For linear regression, I said clearly that there will be a huge impact of that because your correlation and your outliers are dependent on each other part, and it will be a negative relation between them, or negative effect will be there on them on each other. Next part, so yes, you can just think about it. The outliers effect, let me write it here, sorry. So for about the outliers, you can say, in case of classification, or maybe let's say KNN algorithm, will be adversely is adversely affected by presence of outliers in the experimental data set. Okay, so here are we. This is how we can particularly look for these all points. And yeah, that is it. That's what I was talking about. In KNN, you will be having the data points. If you will choose k equals to 3, these three values will be chosen. 1, 2, 3. Suppose this is my data point, and we have to look for if it is supported by 2 or if it is supported by more than, if it is supported by one class and which one is there. So, okay, one more thing I have not discussed here is that how does actually ultimately this is going to be helping us in classifying the data. So, number of support of the data which is there will be the deciding factor. Number of votes. Number of votes. Okay, simple, the deciding factor is the number of votes. If you take k equals to 5, so whichever are closer to it, we will choose the closest 5 value. Okay, we will take here the closest 5 value and then we'll decide that those 5 values are actually predicting this new sample as a 0 or 1. Which is the most support? Which is the number? What is the number of votes for them? So this will be the deciding factor. So number of votes, that's how it will be the deciding factor. Let's take here. If outliers are rejected since they won't closer to the test data, how they will affect the algorithm. If you have eliminated, then obviously there will be no. Okay, let me show you how it could be affected. See, your data points could be anywhere, right? It could be anywhere. It's not that the majority of the data will be nearest to that. Suppose I'll show you the presence of the outlier. Suppose I'll just take here my data samples like this. This is your class. These are all my samples, correct? Now our number of classes. This is my other class. Now suppose my number, there are certain outliers value here. Like suppose few of the class 0 are over here. Okay, these are your two data. Now I'll take my new sample here. Okay, here is my new sample. Now tell me if this should be classified as class 0 or class 1. If my k is equals to 3. That's the effect of outliers. You can see clearly these are outliers term. These are all outliers. This is my new sample. And I have taken here k equals to 3. So with the help of your number of nearest neighbor as k equals to 3, this particular data this new sample will be predicted as class 0 or class 1. So this will be definitely get wrongly classified as class 0. That's the effect of outliers. Okay. So you can easily handle these type of scenario by choosing the good value or good number of k value. And in order to find that, we can simply rely on grid search CV in order to find that what should be the optimum value of k. Okay, clear? So that's it. This algorithm is super simple. We don't have to spend much of time here. There is no maths involved here. It's all about you have a response table and you try to classify on the basis of k equals to 2, k equals to 3, k equals to 4. Here, for binary class classification, one more trick you can use is that you can choose odd number of k to avoid the case of tight distances between the two class. That's one trick you can always use. This is one trick that also you can use. Otherwise, majorly we can find the solution with the help of grid search CV. So as I said, for binary class classification, this is your trick. For binary class classification, number of nearest neighbors. Which is k, this should be an odd number. Okay. Obviously, k, if your number of classes are 2, so you can go for 3, 5, 7, 11, etc. Fine. Clear with everything? The theory is clear. Let's take the practicals. You can drop your questions if it is not clear, or you can just write yes in the chat window if you have understood the working of k nearest neighbors. You can just drop yes in the chat if you have understood how this k nearest neighbors is working. Okay, great. Start a new Jupyter notebook. Start a new Jupyter notebook. K nearest neighbors. K nearest neighbors, or you can call it as KNN. KNN. We can go for the shopper's intention. Manhattan distance formula is also there, similar to the Euclidean distance formula. You can just look for Manhattan distance formula, that could be also used. It is the difference between your, the x1 and y1, but this time you don't take a square root, you don't take a square, but you take modulus of the value, so that you'll be always getting, like I'll just show you through the formula. This was your Euclidean distance, right? Manhattan distance is this one, absolute difference. Let's take here Manhattan distance formula. Manhattan distance formula is given by x1 minus x2 plus y1 minus y2. This is called as your Manhattan distance formula. You can also call it as absolute distance. Absolute difference. This formula is also there, but majorly we use Euclidean distances for our machine learning. Okay, I'm going to take an example of shopper's intention. I mean, there could be other examples as well. You can try to even apply in our previous examples. I think the last example was Titanic dataset, correct? Fine. So let's take this another example this time. Shopper's intention. Whenever you are doing any machine learning algorithm, these four packages will be by default. So I've taken here the distances, all these values. Okay. First, let's get started with my shopper's data frame, which will be given by ad.read underscore CSV. Now I'm gonna give you the URL of the dataset. If you wanted to download it, you can download it directly. This is my shopper's intention that I wanted to classify here. Okay. What type of data type is this? This data type will be helping us in predicting if a customer is likely to buy a particular product or not. What is the intention of the shoppers? Whether or not they will be buying the particular product or not. Got here my administrative value, duration, etc. And on the end we have got the revenue. Revenue is given by false, and revenue is also taken as true. On the basis of following columns, that includes administrative value, administrative duration, international duration. This is all about the duration which is spent over the particular platform, the buying platform, product related duration, bounce rate. These are all related to the term of. This is all related to the term of your Madhu Mohan. Mr. Madhu Mohan, please check the chat window. I just shared the URL. Now I'm gonna share, and you all will be please go back to the same way that we are doing it. Please change your send to option to host and presenter so that it will be easy, that I can check your questions in between and others will be only able to see the codes. Okay, so kindly follow this. I'm resharing the code, and you all please change your send to option to only presenter and host and presenter, so that I can see the your all the questions. And here are your two codes. This is all about the page values, the duration which is spent by the various users over the platform, over the websites. Whether they are spending only on what is the browser they are using, what is the operating system they are using, what is the region, what type of traffic type it is, what is the visitor type, whether they are new visitor or they are registered visitor, if it is a weekend or not, and what is the impact of this on the revenue, whether they have able to buy the product or they are still not buying it. So that's your shopper's intention. A lot of rows are there in this, you can see. So let's get started by taking certain examples here through the shape part. Shape will be showing us that we are having near about 12,330 data sets with 18 columns. Everybody is clear here? Now let's take my values. Please change your send to option 2 from all participants to host and presenter before you send anything. This is for everybody. Yeah. Thank you. No need for this. Now we will first check, just like any other example, we'll first check for missing values. So is null dot sum. We have got 14 missing values in each of the rows, which is very less. I mean, this is quite a very small number. So we can happily drop them by using drop NA. So we can happily drop them by using drop NA. In place equals to true, and those are all dropped here. This is for dropping drop null values. Drop null values. Hello, Mr. Ramesh, please can you just send your send to option to all host and presenter? Okay, participants, here is the next line of the code. So what we did here is that because we had a scenario where just few percentage of the data was missing, so we can happily drop them. All our missing values are dropped. Now the first thing that we can do here is that we can perform some analysis over this. You can try to particularly check for a different analysis here, like you can check the impact of weekend on the revenue if you wanted to check it. What is the distribution of visitor type on the basis of the revenue part? Let's see. First, let's do some EDAs, exploratory data analysis. That's what the visualization is used for. First, let's see what type of, how many samples are there in each classes. SNS.cat plot is used for this. X will be equals to revenue. X will be equals to revenue. Kind equals to count. And data equals to shoppers data frame. Let's make height is just like your fixed size. In order to enlarge the figure, we use height here. Okay. Majority of the data goes into the false category, and a few less percentage of the data goes into the true category. So false is majority, and true is a simple small data is there. Roshan, right? So just check it here. If you are, see this thing I have repeated multiple times, it is not that much complicated. You have to just look for that if there are less number of samples or it is large number of samples. Let's say we are having 1 or 2% of the data which is having missing values. 1% of the data you can always try to drop them, correct? If you are having a number, a numerical value which is very important to your data set, and at the same time that has got a large majority of the data, like you saw in the Titanic data set, I didn't allowed to drop those rows because first of all it was age of the passenger, which is quite a necessary data. Second, the amount of the data, the amount of missing value, the total number of missing values were large. So we are not allowed to drop them, otherwise we'll be losing a lot of data unnecessarily. So in that case, you can simply apply your replace by certain missing values approaches, which will be either replaced by mean or median approaches for continuous data, and for categorical data it will be replaced by mode. That's how it is. Would we impute missing values, drop them, or fill them with a constant data? So that's the answer. When you will drop them, when the percentage of the data is within the range of 1 to 2%, drop them. If it is more than that, try to replace it by your central tendencies. Imputation is what we have learned already, so you can try to do it. You can try to replace it by a different strategy rather than by a constant value. Okay, try to divide them by through certain category here. Okay, clear? Shall we move ahead now? Now, what is this problem statement that you see here? What is this problem statement is called? What you see in the CDA part, this is called as imbalanced class. This is called as imbalanced class, isn't it? A lot of majority of the data is on the false side, and very simple, a very small amount of the data was on the true side. In our previous discussions, we had already discussed about the logistic regression. As far as I remember, in our last discussion, this was on logistic regression. That was the last algorithm, right? And what was that algorithm was all about? The example, I think diabetes was there, right? Diabetes, correct? Project 2, diabetes. Fine. So this was the example that we have taken. See, same thing you have to do it again here, the same part. Here in this case, we have taken the data and we have just figured out the missing value. And also in this case, there was a scenario where we clearly saw that the data that we are having is an imbalanced data. Okay, sorry, in this case, we have directly implemented it. Here is our target data set. Okay, so in this case, I think this was all about handling the missing values. Anyhow, I'll be discussing about that part here. It means it is a new topic for you. What is imbalanced class? Imbalanced class means when we had a majority of the data of one class and the other class is just a small number. So we will try to handle this. That's your first point from this EDA. Second, let's try to check for distribution of the data. This is your distribution of visitor type on revenue. Distribution of visitor types on revenue. Let's pick here my SNS.cat plot. X equals to revenue part. And then we have got kind, which will be equals to count. Okay, using the hue, we will try to categorize our data on the basis of visitor type. Visitor type, we are trying to differentiate. And in order to do all this, we need our data frame. Shopper's data frame, and here it looks like. So what you see here, revenue equals to false and revenue equals to true. These are all your three different categories here. Returning visitor, new visitor, and other. New. So you can see there are a lot of So this is similar to, you can see here in this case, the returning visitor is there. A lot of data are coming back to the platform, which is a good sign. Okay, but majority of them are not contributing to the revenue. That means they might be not purchasing it. And here is your distribution, which are showing the sign that, okay, those who are visiting it, their platform, out of that, these are the contributions. So definitely the majority of the contribution is from the returning visitor. That's the insight that you get. And then it is about the new visitor, and then it is about the other. So that's your insight here. The insight is the majority of the contribution is from the returning visitors. How about if I wanted to target now? Let's not focus only on this part of true. Let us try to closely relate to the particular value that how many of them are actually contributing to the revenue. Let's focus on that particular data. So in order to do so, we have taken here shopper's data frame. We'll take here my column, which will be revenue column. First graph is clearly showing that the insight from this is that it is an imbalanced class. Majority of the data is false, and very less number of data is there for the true. So this is a scenario of imbalanced class. This is a problem. I'll discuss what is the solution after this as we'll progress ahead. Now I wanted to focus only on the data set where the revenue is true, which has been given by here. True and false denotes here. True denotes when, obviously the revenue is true means what? They have purchased the product. These are those customers who have contributed to the revenue of the particular e-commerce website. Whereas these are the details for those customers who have visited their page but hasn't contributed. That means they haven't visited. Didn't do anything. Correct. Revenue equals to false and true is easily understandable. This is all logical here. That we are getting hot here. What? These are all the data that is related to the customers who are visiting their websites, right? So whether or not they are actually contributing to the revenue, that means whether they are actually buying the product or not. If they are not buying the product, for that revenue is false, and else it is true. Else it will be true. Okay, so we have got here my shopper's revenue, which is equals to true part, and we are having here how many data? 1908. Now out of this data set, I'll be trying to simply do the value counts here as per my visitor type in order to actually go and get the numbers. So we'll get for my visitor type here. These are your different value counts. You can see out of all these value, 1470 is coming up from the returning visitor. From the new visitor, it is 422, and for other, it is 16. Now, the same if I wanted to convert them into plot. Same if you wanted to convert them into plot, what you can do? You can just apply the sns.cat plot. sns.cat plot, and in place of the data, you will just provide this. And here are your contributions. So I just created here a special data frame which contains only the data where revenue is yes or revenue is true, and then we have then we have plotted it to actually get to see that how many of them are contributing. So others contribution is almost negligible, whereas returning visitors are there and new visitors are also there. So all of you have please start completing them. That's your this is how you can do. Similarly, you can look for the contribution from the different region. If you wanted to see the contribution from the different region, so you can do that as well. Contribution in revenue. Contribution is in revenue from different regions. Here are your contributions. So maximum is from region number 1, I mean majority of them. And the second highest contribution is from region equals to 3. These are all your different regions will be there. And they are been already categorized as numbers. And you can easily see that if it belongs to the region number 1, what are the contributions? And region number 3, what are their contributions? Okay. So these are the insights that we have taken. You can also look for more insights as there are plenty of scope is there in this data set. You can run among the contribution from the traffic type, region, then page views, exit rates. What is the impact of all these? You can try to study with respect to the revenue. Palette equals to magma is color. If you wanted to plot numbers over this, that is done by plt.text. That is done by plt.text. I think I have taken some examples to display the numbers over the value. Maybe in visualization part I have taken it. If it is not, then I can just show you for this particular example how to display the numbers. Okay, so just because I think Uday Goren is asking about how to display numbers. Alright, so I'll just show you here, okay. Suppose I wanted to show you here what is the percentage distribution. That will be, I'm just showing it, just to give me a minute. It is done by plt dot text, but it is very complicated one. I generally don't discuss it because it makes your plot looks more. I mean, the code is become more complicated. Here, there is no need. There is no space of complicated codes. The point is that you should understand the concept, and that could be understand the complexity. The complex codes you can always learn as you will be progressing ahead. Just a second. Okay, so let me show you here. Suppose we have got sns.cat plot. Now let us store the data fig. Now this fig will be actually, if you will just write here fig.patches, this will be returning you a lot of details about the plot. And from there, one data will be our height details. Spaced grid object has no patches. Okay, let's replace cat plot by count plot, which also do the same thing. You don't have to mention here count equals to, sorry, kind equals to count. Okay, so here we go. Height is also not required here. This is part of count plot. Okay. Got here my patches part. This patches is gonna be returning us the data. So let's wait for p in patches infig dot patches. Just take my height, which will be given by p dot get height, then fig dot text p dot get x, sorry, get underscore x, p dot get underscore width is divided by 2. So this is your coordinates here. See, generally the plot is done by only fig.text. What you see here, get x, width, these are only the positions that we are trying to mention here. Height plus offset value, which is 4. Colon 1.2f percentage. Pick here my dot format value. Where height will be divided by length of total data set, which is shown on data frame. So this is how the percentage will be calculated. Alignment will be center. Now this alignment will be center, and the text font size will be, let's say, 9. Okay. All right. I think in this case I have taken a lot of brackets. One bracket is enough. EOF. So get x 1, then get width divided by 2. Second, height plus 4. Third, starts with the 2 values, dot format, height, then length of the data, Okay, here there is one more closing bracket required where we have to multiply it by 100 to get the data in percentage, and we are done. Just like any other plot, you can use white grid here, and you can also take the figure size. We have given here the height plus 4 as a offset value. So you can see that the things are a bit complicated here. Okay, this is how your data will be added. This is how your values will be added here. Pig equals to SNS dot count plot, X equals to revenue, data, and everything. So let me give you the code part. So if you wanted to add the text, this is the code. But where should be the position of the code? That is a bit complicated. Okay. The value is just this one. This is the value that we are presenting. But where should be this position? That's what makes the code a little complicated here. And if you don't write like this, you will say there is no position of y and s. So that is important. You have to necessarily mention that what is your p dot get x and then p dot get width divided by 2 so that it can position the data, and then you can add some height plus 4 to get an offset value. What's the impact of this, I think? So done here, that's how the things work, and hopefully I've understood it. For these it will be more complicated, so you can try them, but the logic will remain as it is. In order to get the text, use p dot get text. Okay. So let's take the example. So let's continue with our next example here for the KNN part. And let's take the examples. Whenever we have got the situation of, whenever we have got a scenario where the data which is there is a bit less as compared to the class 0, imbalanced class, we can have either two scenarios in that case. Either generate more samples or drop the data with a large number of classes. So here we have to generate more input data for training by using upsampling. Let's take here my shoppers data, stick my revenue here, dot value underscore counts. 10,000 sample is for false, 190 is for 1908 is true. There's a huge difference. I mean, you can see that how much percentage is there for class 0. It is 84.51, whereas true is just 15%. If you will apply any algorithm in this case, your algorithm is going to fall badly. The reason is imbalanced class. So what is the solution? Resampling. Resample using bootstrapping method. To generate data, to generate random sample for each class. From sklearn.utils, import resample. First of all, split my data as per the revenue. It's like the way we have splitted here for false as well as for true. This is for false. Shopper's data frame. Similarly, we will take it for class 1 as well. Just mention here true part with my data frame as 1. If somebody is not able to take the contribution of the revenue part, I have already shared it, so please take this part as well. Okay, so this last part is actually for contribution for the region part. If you have not taken this code, so take it. This is in the end, and majority here, I think you all will be at the same place of data augmentation, so please start working with the data augmentation. In this process, we will be upsampling the data. That means we'll be generating a large amount of data that will be supporting for revenue equals to true. Now let's apply in this case. Let us apply resampling. df_1 upsample. This will be given by resample Now I'm generating a lot of data in this case. 1908 sample is there. I want at least the data support from this has to be 8000. This could be any number. There is no as such rule that it should be made equal or not. I mean, you can make equal these values, so that will be having 50%, 50%, but this imbalance should be eliminated. Okay, so yes, that's correct. We are doing the same thing here. We are generating the random samples with replacement. So from the given data, we are regenerating the new samples. That's what the resampling will be doing here in our case. Now, how many number of samples I wanted to generate? For the time being, I'm saying that I'm generating 8000 samples. Now, this 8000 sample will be enough. In this case, as you know that it will be replacement will be true, and must fix a random state. Random state needs to be fixed because otherwise your data will be generated. Okay, every time you will run it, a new data will be generated. So it is important to fix this randomization. It's like whenever you are generating the random data, must fix your random state. It's like a seed number. So here we go. We have got here my sample data. Now let's merge it. Merge a new sample with df_0. Now let's take here my shopper's data frame 2. I've taken here my upsample data, and here is my value. You can write any number here. There is no as such strictness, but you have to write any number here. I have already spent a lot of time talking about the random state in our previous sessions as well. In the train test split, I have discussed a lot about this. It is similar to that data, you remember, like in this case, we have talked about it. That what is the impact if you don't fix the number, and if you fix a number, then your value will be chosen. This was the same thing, random state. So whether random state is used in the train test? Yes, it is like a seed number. Correct. So we are actually fixing our randomization value so that your model will be not changed. Every time you will run the code, you will get the same output. If you will not fix the random state, the impact is that you will get a different outcome every time you will run it, which is wrong. Now, after concatenation of the both the values, our data will be gone. Dinkar, I have never said that it has to be a three-digit number. When I have never said it, then it could be anywhere. And by the way, in our last discussion, we have taken the random digit state already, this topic. Random state could be any number. It could be one digit, it could be two digit, it could be five digit. Now, from this, from this 1908 sample, we are generating 8,000 samples total. Now let's pick my imbalanced class here, and here are my outcomes. Here are my outcomes. Okay. So let me share you the code, everybody. Up to how much we have taken the data. I have shared the code up to magma. Sorry, shoppers data frame. DF0. Okay, now I'll be sending it from apply resampling. Let me start with that. Next is merge the data or concatenate them. And display the distribution of the class now. Data pre-processing. Okay. There are a lot of data which are, in this case, categorical type. In order to handle the categorical data, we can use label encoder. In order to handle the categorical data, we can use label encoder. There is only one column here that, one is there, visitor type, then month is there. Downsampling will be, you will eliminate the data. Like suppose I wanted to cut down this value, so I'll not select, I'll just select by using ilog. Okay, or maybe I'll just use random and random through the random function. I can just select 8,000 random data. Downsampling is just about selections. Please focus here, everybody. After you have created all this, there are two more there are one one thing that is we have to always handle, that we have to ensure that our this type of data like month, visitor type, this is all about your categorical data. This is all about the categorical data. Okay. So what we will do here in this case is that we will be trying to convert them into numbers. Okay, so one of the method that we can use here is label encoder. You can also try with your one-hot encoding as well by using pd.getDummies. So either you use this or you can use your getDummies part. But ultimately, we have to get rid of these unknown, these all categorical data sets. Sheena. Why are we doing? Because we cannot perform the, okay, let's take an example. How this algorithm is working? This algorithm is working on the basis of distance formula. Here x1 and x2, what are these? These are all your features value. X1 and y1 are what? These are all your features. Correct? In this case, it was x1 and y1. So this is nothing but this is your differences between your all the features. If your features will be a categorical data, how you will compute the distance? Got it? That's the reason. That is the reason that we have to necessarily convert all our features into the numerical term. So label encoder will be used from sklearn dot pre-processing import label encoder, import label encoder, take LE equals to label encoder LE dot fit, so we have dropped the data and we have fitted the model. This is my label encoder. The syntax is you will first call the label encoder function, then you will fit it between the label encoder and the visitor type. After you have fitted it, let's take my shopper's data frame 2. With my visitor type, and let's update it by transformation. Let's update it by transformation of shopper's data frame visitor type again, once again. Okay, we have updated it. Now let's pick my label encoder. Okay, now our data has been updated. Let's see what is the change that we can see in our label encoder. So all they are were now filled with the numbers 0, 1, 2, 3, like that. Your number of sample, you can see that it has been increased to 1840408, which is totally understandable as we have increased the number of data. So that's the first process of how to tackle the categorical data set. Whenever you will be having a categorical data, either you will apply this particular logic of applying simple label encoder, which will be helping us to number them. Okay, like in month, you can give them in numbers like 1, 2, 3, 4. But there will be certain scenarios where you cannot give the numbers to them. Like, for example, if you are having location or maybe education, somebody is having higher education, somebody is having lower education. So it's not a good practice that there you will give the number. Or in fact, one more example you can take gender. So why gender, why female will be 1 and why male will be 0, and why not the other way? So there are many scenarios where label encoder is not logically suggested, as there is no need to give the numbers there. But in that case, pd.getDummies are used, which basically converts the data into a new column and it will be filled with either 0 or 1. So that's particularly called as your one-hot encoding, and you can just keep in mind that it is done by pd.get_dummies, which will be generating new columns and it will be filled with 1 and 0, and that's the reason it is called as one hot. Hot means 1. Okay, another thing that we have to take care, and that is our label encoder. Visitor type, I'll replace it by month. After transformation, our data is now updated. So visitor type is done. Every time you are transforming the data, you have to pass that column and fit your label encoder and then update the month. Let's take my correlations here. TLT.figure. Fixed size equals to 23,15. I've taken here a large size. SNS dot heat map. Again, I'll be taking up here correlation part. Shoppers data frame 2 dot correlation function. A naught equals to true. Color map equals to. You can take any other color options. I'll go for red, yellow, and green. Now, with the help of all this, you can actually select your good features and bad. You can eliminate the bad features from here. Okay, let's look around if any value is closer to 0. And so you can see product related. There is, okay, by the way, product related and product related duration is largely highly correlated. Similarly, you can see that bounce rate and exit rate, they are highly correlated among themselves. It's almost like 0.91, which means that both are almost equal. This is also greater than 0.85. The threshold value is 0.8 or 0.85, depends. So somebody takes 0.8 or 0.5. So you can take here, let's say 0.85 here. Any value which will be greater than 0.85, and if there are, if between two features you are getting the correlations like this, you can easily eliminate that data. Okay, in this case, to eliminate the highly correlated value, either you have to look for the red, dark red, or you have to look for the dark green. So it is easy guess. The highly correlated features will be either on dark red or on the dark green. Rest all are already weaker features. There is no space for the highly correlated values. So any one of these can be dropped. You can take the decision on the basis of the revenue. Revenue versus bounce rate is 0.24. Revenue versus exit rate is 0.33. Which one is a better feature out of these? Anyone? If I have to compare bounce rate and exit rate, which one is best feature? Exit rate or bounce rate? Give your answers in the chat. Which one is best feature? Exit rate, most of you are saying exit rate, which is correct. Bounce rate is not a good feature. Those who are sending bounce rate, you have to revisit. Bounce rate is less in magnitude. Higher the magnitude, better is a feature. It's all related to the magnitude. Don't look for the sign, look for the magnitude. This word I have repeated multiple times. If you wish, please write it somewhere if you can't remember it. Exit rate is 0.33, whereas bounce rate is 0.24. So if you will compare both of these, exit rate is higher. So exit rate will stay and bounce rate will be eliminated. Why we have to do so? Because we don't choose the highly correlated features. Alright, so let's eliminate this. Got here my features. So following the same pattern that we have learned, we have to split the data, the x and the y value. X will be everything apart from this. Product related is gone, bounce rate is gone, and revenue is obviously, this is obvious. So X and Y is there. Now we have to apply the split of the data. Sorry, splitting the data. So I'll take the help from the already available model. So use the train and test split. Use your train and test split. In this case, I have written it as X and Y. So let's keep it as it is. X and Y. I'm splitting the data into 75 and 25. You can choose it anything between a range of 60 to 80 ratio. Okay, everything will be working fine here. Okay, random state I am choosing it 3. 3 I have already tested, it is working really good. So I'll go for this. Now I'll be talking about the k nearest neighbors algorithm. We have taken here. Now I'll go for my number of neighbors. Number of neighbors is my only hyperparameter which is important. Hyperparameters, and we have to tune them to create our best model. So k nearest neighbors. In this case, I am going to take the classifier number of neighbors will be equals to. So I am taking some odd number. Let's say 15. 15 is an odd number. Why I am taking an odd number? Because this is a binary class classification. And then, as always, we have to fit the model. Okay, if you wish, you can try to normalize the data by using min-max scalar. By the way, KNN does not say that you have to necessarily do that. This is related to your parametric type of algorithm. Here, there is no need for that. You can simply fit your model. X train and Y train. Once we have fitted the model, let's look at around. Let's check the score. Let us check the score straight away. While checking the score, you have to provide the X test and Y test. The score will be giving you the accuracy part. It's giving us 77% of accuracy value. It's giving you 77% of your accuracy value. Okay. Now it says that, okay, 77 is not that great, but it is not that bad. What is the impact of if I reduce the number of neighbors on the score? So you're seeing that, okay, when we have reduced the numbers of nearest neighbors, the accuracy is getting better here. We have reached up to 98% here. Let us take number of neighbors as 5, and the accuracy is increasing and increasing and increasing. Looks like here that if we will take number of neighbors as less number of value, then here the algorithm is gonna be better and it's gonna be getting better and better and better. This is all we can figure out. For the time being, we'll keep our values to 15. And then we will discuss one very important thing, which could be not helpful only for finding the hyperparameters for KNN, but for others as well. Like in future, in machine learning section, especially, you will learn about, let's say, random forest and or decision tree. So there, the hyperparameters, the difficulty will be there to decide that how many number of trees should be there for random forest. So that is also a that is also a hyperparameter. You can easily decide it by the help of all these. Done? X-train and Y-train, no. X-train and Y-train are your data sample. Why it should be X and Y? Train data sample we have to use, correct? We don't have to use the entire data. We never train it for the entire value. Row number 37. Oh. X-train and Y-train is not defined because we have not taken these two lines of code, X and Y. Then take your algorithms. I'm resending in the sequence. Please check it. Where you have made the mistakes, which are missing. Please try to update it. And get the score. You got here my score part. Now the next thing that we have to discuss here is that if this is the best model or not. In order to remember, we have talked about the regression metric. Let us talk about the classification metric now. Classification metric. The classification metric include your one accuracy part. This is your accuracy this time. It is not like an R scored value. By comparing your actual and the predicted value. The other is confusion matrix, and the third one is your sensitivity, specificity, precision, recall, these type of terms. Those are really important terminologies which actually gives us a real idea about the classification, how performances. So let's take that Y predicted value first, which will be given by knn.predict, and pass your text part. This thing you have to keep is always in your mind. Whenever it comes to the performance, or we have to check if my accuracy or performance of the model, we have to always rely on the testing data. We have to always rely on the test data. Whatever you are getting, it's okay. knn.predict xtest, what happened here? Instance is not fitted. Maybe I think I have executed them. Okay. I'm getting some accuracy here. Whatever the accuracy is getting is fine, okay? Whatever the accuracy you are getting is fine. This all depends upon how the samples are distributed. So some variations are always okay. We all might not get the same outcome. If your random state will be different, you will be getting a different accuracy score. And your accuracy score will be definitely dependent on this part. You can see different random state is generating different accuracies. A slight difference will be always there. Number of neighbors, when you will change, that will also change or modify your accuracy part. Okay. Once we have fitted the model, it's time to compare the values of this predicted value. This is all about y hat. This is your y hat, which is predicted output. This is all about my predicted output. Now let's compare the other metric. For that, we can simply rely on sklearn dot matrix import confusion matrix. And we can also talk about the classification metric or classification report. Confusion matrix. Can take here my y test versus y predicted value. And here is my performances. The diagonal values are your true predictions. The non-diagonal values are your false prediction. Very simple and very easy to understand this. And if you wanted to convert this matrix into a heat map value, so you can take here SNS.heatmap. You can take here confusion matrix. Take here my A naught equals to true, FMT equals to 0.0f. And we can take my color map equals to magma. You can choose any color options. Okay, the simple representation of this in the plot. As I said, the diagonal values are true predictions for class 0 and class 1. And the non-diagonals are your false predictions. Like you can read this as actual class 0, 2098 are your truly predicted as 0 class, whereas 475 got falsely predicted as class 1. Similarly, we are having some large number of data for the class 1 value. Out of that, 1464 is your total number of data that belongs to class 1, whereas 565 belongs to class 0, which is falsely predicted. Okay, next part is print here my data, and we can take here my classification report. Y underscore test and y underscore predicted value. A naught equals to true, FMT, classification report is enough. Precision, recall, F1 score and support. These are the outcomes. I'll explain you this part a bit later. For the time being, let's proceed ahead and let's finish it. I'll explain these two parts once again in the whiteboard. Please allow me some time. Right now I cannot discuss because I need to first talk about the grid search CV part. Okay. So this is your performances here, but we don't know if this performance is actually good or not. We can only understand it if we are getting the numbers in around that. That is also okay, no problem. Sometimes the plot does comes out to be weird. So we are getting a different. I mean, numbers are, as long as the numbers are coming up, that's totally fine. Now these are the performance of the model. Actually, should have been. I mean, let's try to first go to the grid search. Okay. So in the middle, I wanted to do some grid search CV. I think I've forgotten that. And then we should have taken this part in the end. And then we could have easily made the, part. So I'll request everybody to please add in between some more some more cells where I'll be taking up grid search CV. Uh, this should be before the classification metric so that we don't have to repeat the classification metric part. Please focus here. I'm inserting the cells after the score part. So once you have taken the score, please use plus symbol to add new cells in the middle so that we can take this left one thing which is grid search. Grid search CV. Okay, so let's get started here. From sklearn dot model underscore selection import grid search CV parameter underscore grid. This will be equals to number of neighbors you take here np dot arrange 1 comma 60 values. So you have taken any value here. Okay, I have taken a data. This is my values which will be there for my hyperparameter equals to number of neighbors. Sorry, this should be a parametric value. Sorry, hyperparameter, and done. Now let us take our KNN classification part. Define our model. I'm not passing anything this time because I'll allow this algorithm to be part of grid search CV. As I said, grid search CV will be giving us the best model, and we can find out here the various model performances for the best number of neighbors value. So take here we can take here parameter grid CV equals to 7. Why? What is CV here? CV is part of one more way of splitting the data for training and testing, and it is called as K-fold. K-fold. How many number of folds are there in this? 7-fold. This will split the data into train and test. This is related to nothing, but this is your splitting train and train. Splitting train and test. Splitting data into train and test. Okay, we have got here my CV part, grid search CV, fold. Name is there, K-fold. It will split the data into 7 equal parts. In each part, we'll be having one portion as train, and rest of the portions will be your train portion. Number of total search, number of total value will be 7 in this case. That's your K-fold. Okay, let's speed up here because we need to take one more algorithm today. So let's quickly finish this. Here is my grid search. Store it as a CV, or you can also call it as a GS. This is your final model. Let's fit it. Let's pass here the entire data. You wanted to pass your X train and Y train, you can pass that. Generally here we pass X train and Y train data. Parametric grid, where is KNN? Oh, what is the problem? Okay, something is wrong here. It says param grid. What is the error? Invalid number of neighbors. Okay. BOR. Okay, it will take some time. This will take some time here. Please execute it. Why it is taking time? Because it is taking all the various combinations between 1 to 60 and then it will return me the best number of neighbors. After fitting it, it will give me the best number of neighbors between 1 to 59. Time here. In order to get the best parameter value, in this case only one hyperparameter is there, which is number of neighbors. You can similarly by using same logic, you can also try to figure out here the other parameters value. Okay, and we'll get here the value, and then let's take the score as well. The best score. Now on the basis of that, you can decide that what should be the best outcome, and then finally we will create our final model. So we need to add a few more data, few more cells, which will be for final KNN model. With the number of neighbors equals to, okay, we will decide it after getting the result. Let's wait for this. It will take some time here. Meanwhile, I'll just keep everything ready. We are seeing that number of neighbors is 1, which is giving us the best score of 92. Okay, all right. So that's how you can find out the value. That's how we have fitted the model. Please look for the best parameters. Similarly, you can apply this to the other algorithms where you wanted to choose the hyperparameters. Grid search CV will be super useful there. Okay. When you are not sure about that what should be the exact hyperparameter data that you can use, so you can use your data. Now the question arises here that we have taken the np.arrange as 1. This should be greater than 3 first of all. Yes. So in this case, one thing is there, guys, that you have to take greater than 3. Why we have to take 3? The reason is that we are having binary class classification. 1 can never be the parameter. 1 can never be the parameter, so it should be 3 to 60. Now I'll repeat it and then check the score. I think for 3 only it will get the best fit. So we can finally create our model with the help of number of neighbors as 3. So make a slight change and get the score. Rest all will be also dependent on the same thing. So rest all you can also execute it. And that's the end of your algorithm. Okay, I believe that this classification metric you have already shifted below. Start your, just make a slight change here. This should not be 1 to 60, but better you take it between 3 to 60. And the reason is super simple, that in this case my number of metric is, our number of neighbors is 3. So execute them. I'll talk about the classification report and confusion matrix in detail once we are done with this entire algorithm. So maybe after the break I will discuss them. And then we will take the unsupervised learning algorithm, which will be the last. And after taking that, we can discuss NLP, natural language processing. Okay, natural language processing will be quite an easy topic, and it's a short topic as well. It will not take much time here, I think. And after that, there is another short topic which is related to, our web scraping. I have shared it already. Let me share this particular value here. Please run it for the different data. Get the parameters, get the score, and then the final model will be your KNN for 3. It is going to take some time. Okay, we have got this. The best score is coming out to be 3 now. The accuracy we can take here as 87%, which is really great. Now let's take here the confusion matrix and the heat map about the confusion matrix as well. And also the classification report. So I have resent the data in a sequence once again. If you have executed them, it's okay. If you haven't executed the bottom part, do execute it, do take the code from the chat. Okay. So all points are clear here. What is the role of grid search CV? It's all fine. This is one of the good things that we have to actually find the best hyperparameter value. Okay, completed. Those who have done till here, please write yes in the chat. Those who have finished it, please write yes in the chat. I'll wait for 1 more minute. Best score indicates the best accuracy that we have got for the best parameter. Best score is the best accuracy. So basically it is saying that the number of neighbors, when you take it as 3, it should have given 86.06. But when we actually implemented it as an explicit algorithm, then it is getting better here, which is going one more value up, which is 87.4. So best score is the best accuracy for the best parameter, which is 3. And from here, you can easily choose your best parameters. Remember, for binary class, it will be 3 or more. For multi-class, you have to look for at least one number larger. Binary means 2 class. So minimum number of neighbors will be 3. Similarly, if it is let's say 4 class classification. So minimum number of neighbors in that case will be 5, the next higher value. So for even value, you should take odd numbers. For odd numbers, you will take even values. Okay, like for 3 class classification, you will be taking the outcome as your number of neighbors will be 4 in that case, the next higher value. That's the logic that you have to implement. Alright, so that's it. This is all about our KNN part. Super simple, but I have taken one difficult problem and there was some more good insight about the coding thing we have learned here, like this grid search CV, which could be implemented to other algorithms, and how to handle the issues of the data, correct? After we are done with all this, you can just remember these logics where they will fit in according to your problem statement. Like I have implemented here label encoder. So label encoder is implemented whenever we have a categorical data. So next time when you see categorical data, must implement this uh, label encoder part of pre-processing this categorical data into numerical form. Similarly, if you have got an imbalanced class, you will be particularly upsampling one of the class here in order to make these sample distribution almost equal or closer to each other. Okay, so that's it. This is all about our data distribution. Let me start with my. Those who haven't done, you can do it with the help of the chat part. Those who have finished, I'm just starting with a polling activity. Please give a poll and then you can go for the break. I'm here for next 2 more minutes. If anybody is facing any error or something, you can post in the chat. I'll be happy to help you all. Polling is on, and if anybody want my help, please do respond in the chat. If anybody is getting error, all right. So those who have already contributed in the polling activity, please go for the break. Poll is on. Those who have already given their feeds, please go for the break. Sudarshan Ganesh. Okay, I'll just check it if you can do it. It all depends upon, see, there are other topics as well. So usually for one algorithm, we get um, only that much amount of time to particularly take one data set. But okay, I'll extend in the end and then I'll take it. All right, so I'm starting the clock and let's see all these things after the break. See you all after the break. Break will be for 17 minutes. Remember, break is for 17 minutes. Hello everybody, welcome back after the break. Welcome back after the break everybody. Please show your presence in the chat. Participants, please show your presence in the chat. Participants, please show your presence in the chat. Let me let me eliminate this part. Okay, let me take a classification report part. Let me explain you that. Let me explain you the classification report. In the first part, I think first is confusion matrix, right? First, let's talk about the confusion matrix. So let's take an example. Suppose we are having some 500 samples here. This is my 500 sample data. Out of this, the sample distribution is 250 belongs to class 0. 250 that belongs to class 0 here. And on the other side we have got class 1. The other side we have got class 1. So equal distribution of the classes are there. Class 0 is 0. This is your class 0 performance. And the other one on the other side we have got class 1 data. Now let's feed this 250 samples into the machine learning algorithm. Then on the other side we have got again ML algorithm. Let us take your performances here. Imagine here that class 0 is there. Out of this all class 0, the KNN algorithm successfully able to predict 220 as class 0 and 30 samples as your class 1. Total number of samples 250. Out of that 220 got predicted as class 0 and 30 got class 1. Which one is true prediction? Which one is false prediction? Actual value was 0. Okay. Actual value was 0. So predicted value will be 0, will be considered as true or false? True, correct? Real class was 0. So if it is predicted as 0, that will be considered as true. Class 0 will be not false. How it will be false? Class 0 is there, actual class 0. It also got predicted as 0, so it will be considered as true predictions. Okay, now next. On the other side, we have got 220. So out of this 240, or maybe let's take 230. 230 got predicted as class 1 and 20 sample got predicted as class 0. 230 got predicted as class 1, whereas 20 got predicted as 0. So actual class is 1, actual class is 1, got predicted as 230. So actual class as 1 and got predicted as 1. This is true or false? This is true or false? Again, it is true. Right. Actual class was 1 and it got predicted as 1 again. Let's convert this distribution of the outcomes in terms of a matrix, which is called as confusion matrix. A confusion matrix is a matrix between your true predictions and the false predictions. This is your actual value and on the other side we will be having predicted outcomes. Class 0 and class 1. Okay, now tell me. Actual class 0 got predicted as 0 as well. How many of them values are there? Actual value as 0, it also got predicted as 0. How many of them? $220. Actual value 0, predicted as class 1. How many of them? Actual value 0, predicted as 1. 30. Similarly, actual class 1, predicted as 1. So actual class 1, predicted as 1. How many of them? 230. Actual value 1 got wrongly predicted as 0. Actual class 1 got predicted as 0. How many of them? 20. This is all about your true predictions. So this is your true value. Okay, one more thing. Let us understand in this case negative class is there. Negative class is nothing but it is your class 0. Positive class was class 1. Positive class was class 1. So why the values are getting wrongly predicted? You cannot expect a machine learning algorithm to give you 100% accuracy. That's why. There will be certain predictions which will be wrong as well. But majority of the data should be correctly predicted. When we say accuracy, we say 80%. We don't see 100% accuracy. If you are seeing 100% accuracy, then either your sample was too easy, okay, or your or your model has been overfitted. So here you go. These are all your diagonal values. As I just said, diagonal values are your true predictions and non-diagonal values are false. I have said one thing as well. The class 0 is called as a negative class and class 1 is called as a positive class. So this one is true prediction or false prediction. This 220. This is true predictions or false? Actual class 0 got predicted as 0. True or false? True. Just now I discussed one thing, that class 0 could be also termed as negative class. So this is true negative. Okay. Actual class 0, real class 0. The model has predicted it as 1. True predictions, false prediction? False. This is positive or negative? It is class 1, right? What is class 1 called? Positive. So FP. FP. So T and FP. Next. What about this part? This is true or false? True. This is a positive class or a negative class? 230 is a positive class or a negative class? So write this. This is TP or TN? TP, correct? This is a positive class. What about this? Write the short name for this box. Write for this part now, by similar logic. First, check if it is positive or negative, and then look for whether it is negative class or it is a positive class. So this is your false and negative. Just now I said that diagonal values are true predictions and non-diagonal values are false. It is easy to remember. Non-diagonal means it will be false, and diagonal values it will be always true. So don't make mistake in true and false part. Diagonal values, true predictions, non-diagonals will be false. Now next question arises whether it will be negative or positive. That you have to check whether you are looking for class 0 or class 1. Okay? Class 1 is positive and class 0 is negative. How does the accuracy is calculated? Just remember, I'll repeat again, that diagonal values are true predictions, and non-diagonal values will be false prediction. True negative should be 230. What is negative class and what is positive class? First answer me that, Mr. Sudarshan, sorry. What is positive class out of this? Positive class is class 0 or class 1? Class 1. What are we trying to monitor here? Class 1. So how come this will be true negative? Negative means class 0, positive means class 1. Okay, accuracy value is given by true negative plus true positive divided by total number of samples, which is all values, Tn plus Fp plus Fn plus Tp, sum of all the values. True negative plus true positive divided by total number of samples. Fine. So that was all about your first section. This is your classification report number 1. Next part that we have to monitor here is, the next thing that we have to monitor in this will be the classification report. So let's take that. Classification report. In case of classification report, to look for sensitivity, sensitivity is the ratio ratio between how much samples are correctly predicted as positive, given by true positive. To how much are actually positive? To how much are actually positive? Sensitivity. Let's take a simple example. Suppose there is a COVID, to conduct the COVID positive or COVID negative, we take RT-PCR test. We conduct RT-PCR test here. Let's say already 100 COVID positive patients are there. We are having 100 COVID positive patients. Out of this, when the test is conducted over these COVID patients, RT-PCR successfully able to detect 80% as positive and 20 it has detected that it is negative. We already knew that these are all COVID positive patients. Still, the RT-PCR has failed for 20 people to detect it. That will always happen. You will be always have the false negatives here, correct? And the true positives. So let's take that mathematically. The sensitivity is given by true positive upon true positive plus false negative in terms of percentage. True positive plus false negative in terms of percentage. This is your total number of positive class. These are all your total number of positive class. Okay. This was about sensitivity. Sensitivity is all about finding the accuracy for finding the performances for true positive. Sensitivity is nothing but this is also called as a recall. One of the same thing. Sensitivity is similar to recall, or you can call it as recall is similar to sensitivity. Both means the same thing. Part number B. Specificity. Specificity. Rate of correct prediction. Rate of correct prediction of samples. That are predicted as negatives. That are predicted as negative. Mathematically, it will be represented by true negatives, performance, true negative upon true negative plus false positive. We have got here 100 COVID negative patients. Same rule. On these COVID negative patients, we are running the test, and I wanted to check that out of all 100 patients, how many of them actually have been detected. 80 goes with a negative and 20 goes with a positive. So what will be the accuracy? What will be the percentage of specificity? If out of 100 patients, 80, which were all COVID negative, so 80 got detected as negative and 20 got detected as positive. So what will be the specificity value in this case? Out of this example, what will be the specificity for COVID for RT-PCR test? It will be 80%. Similarly, what will be the sensitivity for RT-PCR test? What will be the sensitivity on the basis of performances? This will be also 80%. Both will be 80% each. Okay. So these are your two values. Now, I think one more is there, which is called as precision. So sensitivity is all about checking the accuracy for the positives, whereas specificity is about negatives. Accuracy of actually positive value from overall predicted positives. This will be given by true positive upon true positive plus false positive. These are all my true positives. F1 score, harmonic mean of precision and recall. Harmonic mean of precision and recall. This will be given by 2 into precision into recall upon higher the better. F1 score should be higher the better. We are done here. All these are your classification report. So hopefully I have understood them now. In depth we have discussed it. Numerically, what is the meaning of it, and what is the actual implementation, and how does they affect our classification reports. Hopefully I've understood it through this example. Sorry. Hopefully I've understood through this example now. Okay, now you can fit in here. The only thing which is not available there is support. Support is your total number of samples. F1 score is harmonic mean, which is the average between your precision and recall. Precision value we have just talked about. This is only about the performance of the true positives. So what is the true positive from the actual positive in the class 0? So basically it will be between 2158 and 164. So in that 93% it is. Whereas here for class 1 you will say 1865 is the correct prediction, whereas 415 are your false. So the performance has dipped here to 82%. Recall is for each classes, so 2158 and 415. Similarly 1865 and 164. So these will be detected here for the recall part. F1 score will be the average and the support is your total number of samples. Y-axis, where is the y-axis here? Y-axis is actual class and x-axis is the predicted class. This is the actual here, and on the bottom you will be having predicted. This is actual and this is predicted. Okay, done. So now let's discuss about the next thing. Next algorithm, in fact, and that will be about the unsupervised learning algorithm. The unsupervised learning algorithm. Let me check if I have already stored them. Okay. So it's already been saved. Next algorithm is your last algorithm, in fact, unsupervised learning algorithm. Clustering. Clustering is nothing but it will be a group of the data on the basis of similarity here. Like for example, you can see the sample distributions here. These are all your sample data. Each point taken here my x value and y value, x1 and y1. Clustering is used to extract the structure of the data, and this is also used to identify the groups in the data. So within the data, we are trying to identify them as a part of the group. There must be some similarity point here. So how does we will try to convert them into a clustering part? So there could be something like this. Suppose these are all my samples that we have initialized at the beginning and said that this is your centroidal value. At the beginning, these are all my centroid 1 and centroid number 2. Now, what we will do is we will try to compare the distances between these two centroids for all the samples, okay? Why we have taken only 2 centroids, why not 4 centroids? This I'll be answering it as we progress ahead, but for the time being, understand that in this case, we are trying to pick only centroidal value. And the centroidal is also called as means, and that's why the name is k-means clustering, because here we are taking the mean value in order to group the data into clusters in order to group the data into clusters. So every sample, each and every sample will be compared with both the classes, both the centroid, sorry. And we will check here that which one is nearest. Either it is closer to the centroidal number 1, which will be the criteria to create one cluster 1, or it is closer to the centroidal value, or it is closer to the centroidal value 2. Either they are closer to centroid 1 or centroid 2. You can call the centroid value as mean value or means value here. Okay, once we have compared if it is closer to the centroid value 1 or centroidal value 2, we will optimize it. That means we will try to shift these values. We will try to shift the position of these centroidal value, and finally, this is your optimized result. So from here to here, there will be lot of iterations. So there will be lot of iterations here. Number of iterations will be large here in between. So first it will check this as a centroid value, then again optimize the cluster according to this, then again recalculate the centroidal value, then again shift the results, then again recalculate the centroidal value, again reshift it, and this process will keep on changing itself until and unless in the end we are left with a centroidal value in the center, or it should be closer to all these values. Okay, this is your centroidal value 1 and centroidal value 2. And you know that centroidal is nothing but it will be your sum of xi divided by number of samples. So let's pick here my xi value, total number of samples, and let us divide it by number of samples. This is your mean value, this is your centroidal value. Okay, so that's it. This is all about here the data. Unsupervised learning model, K-means clustering. K-means finds the best centroid by alternatively assigning random centroids to a data set and selecting the mean data points from the resulting clusters to form the new centroid. It continues this process iteratively until the model is optimized. As I said, initially you will be having some sample, some data, okay, some random data will be chosen. This is your random sample, suppose. So any random sample 1 and this is your random sample 2. From the given data set, they will be initialized as centroidal 1 and a centroid 2. Centroid 1 and centroid 2. Once we have defined our centroidal values C1 and C2, we will try to compare the distances. So if this sample belongs to centroid 1 and centroid 2, how do we will check it? We will check it. Then, so compare a sample to nearest to both the centroids. That is C1 and C2, and check which one is nearest. In order to do so, you can again rely over the Euclidean distance formula. Euclidean distance will be used to find the Euclidean distance will be used to find if this sample x1 and y1 is closer to this sample or is closer to this sample. After we have calculated it, we will assign that group to this particular data, and then we will keep on iterating it. We'll process this, we will iterate it until the model optimizes. So again, your mean will be shifted here, your cluster will be also shifted. Again, your mean will be shifted and your cluster will be shifted. So this process is your k-means. So k-means clustering. Now, if your last two cluster remains unchanged, that means it has been already optimized. There is no need to further iterate it. There only it will stop. If the last two result does not show any update, that means all your samples are already been assigned to the designated optimized cluster. So these samples belongs to cluster 1 as they are all closer to this centroid or mean value. Similarly, this will be your second centroid value, which is cluster 2, which is helping us to create our cluster 2. Now, mean is clear, clustering is clear. What is K? And how does we choose the K? Mean part is clear, guys. How does it is working? It's quite easy. Okay. You can think about for a minute. It is closely related to the KNN algorithm that we discussed already. The only thing is that KNN was a supervised learning algorithm. There also we were checking if it is closer, but in that case it was number of neighbors. The deciding factor here, the deciding factor is the centroidal value, which will be first chosen randomly. Then according to that your samples will be clustered, and then this will be keep on iterating itself and optimizing it. Okay. So new value will be generating the new centroidal value, and as you know, the centroidal value will be calculated by simple sum of the samples that belongs to that particular cluster divided by n. So for the first time it was a random choose, but this particular data, this particular value is a sum of this all data divided by n, which belongs to your cluster 1, and this is your new data. This is your new data. Fine. So now again the new central value will be calculated, and according to that your clusters will be also formed. Alright. Now as you can see here that your central values has been shifted here and here. We will check if this sample is closer to this or this. Definitely this will say that no, this is not a red cluster, it is a blue cluster. So this will be again optimized, and after optimization again new cluster centroidal will be calculated. So this is your iteration number 2 where the new centroidal value is computed. You can call it as your C1, and this could be called it as C2. Then again these values will be shifted, and your new centroidal value will keep on changing itself until the last two iterations doesn't show any update. Okay, so everybody understood it? The concept of k-means is clear to everybody, yes or no? K-means is clear to everybody? Okay. Now furthermore, in order to take some examples here, Let me take one more example of how to find the K. Okay, how to choose K. Answer lies in elbow method. Okay, elbow method. So suppose we are having the data in this case. This is all about my samples, right? Let's pick my data. Suppose we have suppose this is my cluster number 1, which has been already calculated, and this is my cluster number 2, which has also been calculated. Now let's pick my data. These are all my sinusoidal values. Both of these are my sinusoidal. Elbow method is basically computed by taking the distances between the sample and the sinusoidal value. These are all values you have to calculate. The distance between sample and the sinusoidal value. There is a name for this. There is a name for this. This is called as WCSS. Within cluster sum of square. Sum of square is what? The error term. Okay, the difference between your sinusoidal value and the sample within cluster sum of squares, WCSS. Within cluster sum of square, WCSS. This is my sample data, x1, y1, and this is my sinusoidal value, and this is my sinusoidal data. So WCSS is actually given by formula of where we have to check the differences between your all the samples. So let's take the formula here. Within cluster sum of square. Within cluster sum of square, which is given by j equals to 1. This is for k cluster. So j equals to cluster value 1 to k, and we have to take here xi that belongs to cluster j. Xi that belongs to cluster j. Now let's take the differences here between xi minus the mean of the cluster. X bar j is the sample mean in cluster J. Sample mean in cluster J. Fine. So we are taking here the differences between your sample and the xj bar. So remember that this is your xj bar in this for cluster 1 and cluster 2, and this is your xi value. So we are trying to compute here the distances between them. Okay, we are trying to compute the distance between this and your xj bar. What are you responding to, guys? No, for no, why means what? So here it is. This is how your WCSS value will be computed. This is how your WCSS value will be computed within cluster sum of square, where we are taking the differences between your x sample and the centroidal value. So this is your centroidal value, and these are your samples that belongs to the centroid. Okay, already I have explained it. Xj bar is your sample mean or centroidal value, whereas xi is sample that belongs to cluster J. Sample that belongs to cluster J. Okay, so there it is. We are done with all my data part for K cluster. K is your total number of cluster. K is your total number of cluster. K is your total number of cluster. Now coming back to the method, elbow method. Elbow method is helpful in choosing the K. So what happens is when you create a plot between your WCSS and your number of cluster value of K. Okay. We create a plot between WCSS within cluster sum of square versus K value. So for different K values, we will be having the separate values, separate outcomes, and here are your terms. This dot belongs to your K cluster, and you have to look for a data. Won't be increasing this much. Sorry. So for different K values, you are able to see the separate WCSS, which will be the optimum value, the elbow point. Now you have to look for your elbow of your hand. So that type of shape will be created by this curve. To make the thing simple, you have to look for that particular point where after that the curve becomes flat. After that your WCSS values with respect to your number of cluster becomes flat. So here we go. Number of cluster K equals to, so this is your K equals to 1, this is your 2, this is your 3, and this is your 4. So number of cluster equals to 4. Okay guys, so that's how the plot will be created. Hopefully you have understood it. All clear? Now we will be using this theoretical part to create our example. Let's take the example. Hopefully you have understood these points. Now let's take them. To understand it better, we need the presence of k-means clustering here. K-means clustering. K-means clustering. Now in this case, we can take an example of mall customers. We'll try to group here the mall customer data. We'll try to create a cluster between the mall data here. So let's take that. A k-means clustering. K-means clustering. First of all, just like any other example, I'll take the distances, I'll take the important packages. Now let's pick my mall underscore customers, which will be given by pd dot read underscore CSV, and I'll give you the URL to give you the data set. Mall underscore customers dot head function. Display the first 5 result or what? Head is always head. So these are all my data. We have got customer ID, gender, age, annual income in $1,000, and spending score between 1 to 100. Add function is always gonna be using for only one purpose: display the data so that we can see our data and columns. Okay. Now in this case, we have to look for the shape of the data, which is 200 cross 5. So I'm sending you this all shape. Next is missing values. Let us just check if we have got any missing values or not. Mall underscore customers dot original dot sum. So this will return me all zeros here. This will return me all zeros. Okay, customer ID 0, gender 0, age 0, annual income 0, spending score 1 to 100 0. Let's pick here my data, which is gender dot value underscore counts. Got here my 112 that belongs to female, and for male we are having 88 samples. Okay, let's do some EDAs here. Let's see the gender distribution. Just like the way we have created certain plots in KNN, you can do the similar thing. Count plot or cat plot, you can choose anyone among them. X equals to gender, data will be equals to mall underscore customer. Super simple data set. Quite a simple example I'm taking. Okay, so that's your gender distribution. Similarly, you can look for the distribution of your other categorical data or discrete form of the data, which is annual income and spending score. We all know that spending score will be between 1 to 100, whereas annual income will be giving us the idea about what type of range of the customers are visiting the stores. So let's see the distribution of customers visiting store or visiting mall. Same type of plot, SNS.count plot. Replace your X from gender to annual income. PLD.figure. This is all about your distributions. We have got the annual income, which is given by your $1,000, and these are all your different annual income, ranging from $15,000 to $137,000. Ranging from $15,000 to $137,000. Let's use this. Now the next distribution could be, just replace your annual income by spending score between 1 to 100. So you can see the same distribution of the customer visiting mall. For different spending score. Now let's make a plot for the similar type of data, which ranges from 1 to 99. Maximum score is 42, which has been allocated to 8 customers. The second top best is 55 spending score, which has been given to 7 customers. And then we are having scores like 46, 73, which has been allocated to 6 customers each, so on. There are many spending scores which has been allocated to only one customer, like 99, 98. These are the scores which are been given to only one customer. We are having only 200 customers data in this case, and here are they. Now, remember, in this case, there is no target here. We don't have a numerical label as a target. What we have rather here is your features. So X. Now, just for what I'm doing here is that I'm just taking here only 2 features. So you can use here .iloc. You can slice the data for 2 columns, 3, 4. Got here my annual income in $1,000 and the spending score, which is your annual income $1,000 and spending score between 1 to 100. So all of you please start working here. These are all of your customers and all your features. These are all your features. Now using all your features, we'll be first giving the chance to the elbow method so that we can find the best, number of clusters, pardon. Elbow method is used for finding the total number of, so from sklearn dot cluster import k-means. Now let's pick here my use elbow method to find optimum number of cluster where we are taking WCSS versus value of k. WCSS equals to, we take a square bracket, we take a list of it for I in range. Now, in order to create a elbow method, in order to implement the elbow method, what we take here is that we take a range of the k value. You can take any range, there is no boundation for this. Okay, I am taking 15 range of the cluster, starts from 1 cluster to k equals to 15. And now it's time to implement the model. K-means equals to, pick your K-means algorithm, number of clusters, which will be equals to I. K-means plus plus. What is the use of K-means plus plus? I'll explain you in the next part in the final model. Number of iteration are important. So I'll go for 300. And the number of initial value will be 10. Random underscore state. Fix a value as 0 maybe. Pick my K-means dot fit, and you will pass your all x value in this case. There is no need to split the data into train and test. WCSS dot append And in order to calculate here, what does we need? We are calculating here WCSS value, right? Within cluster, sum of a square. So inertia is what we have. A lot of warnings are coming up. Why? Will it come for all the values? Definitely, I need to eliminate this warnings. Import warnings. Warnings dot filter warning. Now there will be no warnings here. Okay. First import your k-means. Then take a different range of k, and for a different range value of k, calculate the new value of WCSS. Calculate the new value of WCSS. Present it here, WCSS. Here is my data. Let's make a plot. Okay, so here is my plot. Color will be equals to k. And here is my value. If you wanted to take all these other data, just wanted to increase the size here. So here it is. Okay. Now you have to look closely here that for which particular value of k you are getting this result. Okay. One more thing, if I'll add, it will be much more clear, and that is SNS dot set underscore style white grid, or you can also take a dark grid. So for k equals to 4, we have got this value. For k equals to 6, we have got this value. Where is the elbow point? Now you have to look for where exactly the elbow is. Elbow, just like an elbow of the hand. So look for the value look for the value where the particular point is. After that, the curve becomes flat. So tell me, what looks here, the optimum value of k? What looks here, the optimum value of k? This you have to think. That's the answer we'll be getting it here. This is not your final model. So you have to look for the optimum value of k. Where is your elbow? There will be only one point. So pick between any value here. Nine. Somebody is saying 9. How come here 9 is showing you the elbow? Elbow. Elbow of your hand. Just think of this is your elbow of the hand. This is a hand. You have to look where is your elbow. Think about, imagine this is your hand. So where is the elbow? That's how you have to think. Where is the elbow? Now you all have understood. Mostly it will be k equals to 5. K equals to 5 is your elbow, correct? Because after that, the point is that these all values will be, there is nothing like 4.5 or 4.6. Either it will be 4 or it will be 5. There is nothing like 4.5. So either it will be 5 or it will be 6 or it will be 4. So where is the elbow? At 5. Clear cut it is. After 5, the curve is getting flat. There is no steep point. The last fall, the last steep point was just before k was at between your k, at 5, k equals to 5. And also think about some imagination here. Where is you are getting the elbow point? So at k equals to 5, exactly in the middle. So the optimum value will be k equals to 5. That's how you will be finding it. Take the decisions, and there will be no value like this decimal and all. Between 4 and 6, the value is 5. Optimum value of k equals to 5 is there, and according to that we have to create our plot. K means plus plus. What is the utility for that? This is used for selecting the initial cluster centroidal value in order to speed up the convergence. In order to speed up the convergence, we have to declare our k means clustering initial value, right? So k means plus plus is used to do that. With the help of this, we choose our initial cluster centroidal value that I have discussed here already. If you will pay attention here to the details, what are we trying to do in this case is that this clustering thing initialized itself first as any two random data will be chosen as cluster. Depending upon what is the k value, in this case k was 2, so 2 samples will be chosen. If k is equals to 5, so 5 random data will be chosen from the given data as centroidal term. After that, so how does these 5 values are chosen? By k means plus plus. Next will be, that is a smarter way of choosing, so that's just your hyperparameter value. Next is your maximum iteration, so number of iteration is 300, which will be, for that many points, this all will be iterated. And we will hope that before 300 iterations it reaches, our final cluster will be optimized. And in it is your number of time the k-means algorithm will run with different centroidal seeds. Okay, so these many times your entire cluster will be executed. It's not that just you have decided the centroid and your cluster will be created. It will run for different times to verify that whatever the result we have got, that is your final outcome. So these are the important points, which are the hyperparameters in our case. These are the hyperparameters. So in case if you don't know that what should be the good value of maximum iteration and number of init, you can take the help of grid search CV here as well. Now just like the way we have fitted the model here, we will take k-means dot fit and pass your x. Similarly, we can take here y underscore clusters. This will be equals to k-means dot predict. We can take here x. No, it is not fixed. You can change these values. Nothing is fixed here. These are all hyperparameters. Number of clusters you will decide it by the help of this plot. Like I have given you the idea here that how you can choose it. Similarly, the maximum iteration is just a number, n in it, which is your number of times the k-means algorithm will run with the different centroidal seeds. So 10 times it will be executed for every new centroidal that has been calculated. So it will be iterated 10 times in order to finally get our model. Finally optimize it for that one centroidal value. Then again new centroidal will be calculated, and up to 300 times it can run. Up to 300 times it can run to find different combinations of centroidal data. Once we have taken all this, our final cluster is ready. Okay, so once it is done, let us find the centers, and here are my cluster centers. Using this cluster centers, these are all my centroidal value, of course. So that's your cluster part. Okay, and we have also got the cluster predictions as well. We've also got the cluster predictions as well. Yes, we can see the cluster with the help of scatter plot, correct? That is our next part. So first of all of you complete till here, and then I'll discuss the visualization, which is my cluster visualization. Speed up, guys, we need to finish one more thing here. All right. So once we are done, just drop done in the chat. Then I'll discuss the next thing. Okay, so once you have taken all this example, once you have taken all this, k-means does not have, I think you have not executed it properly then. If your k-means is not available here, then obviously your cluster centers will also not appear. Just check if your k-means is defined first. Anyway, let's go for the cluster visualization. As I can see, majority of you have already responded done in the chat. So let us quickly create a plot. Okay, so in order to do that, yes, you can have a different results as well, no problem. Clusters number could differ. I'm getting 111 here, you can have all zeros. That's totally fine. What is important is your samples will belong to certain cluster value. X underscore array equals to np dot array, and we'll take here my x value, and then we can take here your x array dot as a type. And this function will be returning us the outcome pld.style.use ggplot. Now, first of all, in order to create a scatter plot, we have to split the data as per the number of clusters. So X will belongs to x underscore array value, and I'll be trying to split it with the help of y underscore clusters. Let's compare if it belongs to 0 or not. This is your first data and this is your first value. Next is your y value, which will be taking up your another feature. So to take another feature, we have to take your next column. Okay, now place this x value and y value inside your SNS dot scatter plot. This is all about our data here. As you can see, these are all my data that belongs to cluster number 0. Take here my label. Cluster 1. Size of the plot is 50. Now this will be repeated 5 times. 1, 2, 3, 4, 5. 0, 1, 2, 3 and 4. 4, 3, 2, 1. Cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. You can use different methods as well. I mean, you can use not just the loop, but you can also convert this data into a data frame and then also you can use it. Ultimately, we have to make a plot. Okay, so there we are having. You can place this y cluster and you can combine it with the x, and then you can just simply write hue equals to, and then you can make a plot, and then you can say that y equals to some cluster data, and that's how you'll see the values. Okay. So x done, y done, our clusters are created in different colors. I'll just take the help from my past codes to, okay, what about the sum total value? So sum total value will be also following the same sequence. The only difference will be that you don't have to take the x and the y in this way, but you have to take it in terms of k-means dot cluster centers, all values and 0. Here is my value and that's how it looks like. Also you can have the titles just to create our plot part. Okay, make a plot. That's how your cluster will look like. K means clustering mall customer is ready. All your 5 clusters are also ready. Also sum total values are also, you can see them. Okay, please finish this. I'm sending it from this line. First, display your Y clusters. Typecast your X array into an array form. And then convert them into nice plots. And then add your labels and your scatter plot to create your sum total value. S is the size of the plot. S equals to 50, S equals to 100 is the size of the plot. Alright, so done here. What B size pressure in such type of what? B size, what size? Size? Is it size? This is size of the cluster, Baba. This is size of the cluster. This is just a size of the size of the cluster. This is there, right? The bubble plot. It is size of that bubble plot. So if you will choose like 10, so according to that your size will be small. So you can see 10 is this. If you will choose 50, then bubble size will be large. Similarly, if I'll be taking up this cross, this is your size of the sum total values. If I'll choose this cross as 50, I'll get a small. If I'll choose it 150, then it will be a bit larger. These are just numbers, these are just changing the size of the cluster part. Completed here. K means instance is not fitted yet. So you have not taken the code properly. That means fitted means just take this part. This is for every who is there. Ram. Mr. Ram, I'm sending the code once again. Start with this line. 1. then fit, then clusters, and then cluster centroids. Done. So these are all your values, and that's how your second model, that's where your unsupervised learning ends. So you have taken enough examples. Rest all you will study in your machine learning part. Data science, for data science, this is more than enough. I mean, you will see some of the things will be repeated in the machine learning itself. As far as data science is concerned, this is more than enough. You don't need more algorithm supports. 3 we did for the supervised, 2 classification part, and 1 is unsupervised algorithm. Now tomorrow I'll start with my NLP part and so 2 lessons could be easily completed tomorrow. One will be web scraping and the other one will be your NLP part. These 2 examples, these 2 we can take it as these are all practicals part. There will be no theory discussion on them required. And then we'll be left with I think one more algorithm. Sorry, one topic, one lesson, which will be Python integration. I'm not sure like if how this is planning to get integrated, but yes, I'll definitely discuss the theoretical aspect of this. But SciPy is already taken. SciPy is not to be discussed as a separate topic. You see that we have discussed about many stats terminologies. There I've used the SciPy. So there are many stats part, especially normalization part or all there. You can directly use the SciPy thing. So that is just a package discussion. I'll just check if I'll get some time here for whether data analysis, KNN, supervised or supervised learning should be undertaken. Whether data analysis, look for what is the data that has been taken here for whether. The older one, right? You hopefully are not talking about the updated version. This weather data you are talking about for the older part, right? Or it is just your own generic question? This depends upon if you are, I mean, see, this unsupervised or supervised is dependent upon your label part. If your label is there, then you will apply supervised. If no label is there, then only you will go for unsupervised. But yes, unsupervised learning is kind of a classification only. As you can see that with the help of clusters, what are we trying to do? We are trying to cluster them. Real-time data will only need the presence of your Hadoop and all, I mean the big data part. Like PySpark, using PySpark, you can do that. Similar type of things could be implemented. Which type of label we need to check it from the data? Day 1, we discussed about this. What this question you are talking about here, the supervised learning example. When I started the discussion of what is supervised and what is unsupervised, there itself I made it clear. If label equals to yes, what is the nature of label? If label equals to continuous, then it is regression. If label equals to discrete, it will be classification. If no label, clustering. I'll repeat again. If label equals to yes, there are 2 possibilities. Either the label will be discrete or no, there is no need for TCA in this case. Principal component analysis is better, will be discussed in the machine learning because there you can actually implement it. Here in data science, I mean, in machine learning part, you have a dedicated topic. I think after this, you will be having a machine learning session as well, right? Am I correct? Roshan. So, yes. So, in that, you will study better. Sir, is that possibility possible open to read .dat file? Yes, .dat file could be read by the help of .read.csv. That's correct. .dat file could be read with the help of read.csv, read underscore csv, sorry. pd.read underscore csv. But yes, you have to look for what is the nature of the dat file, what is the delimiter, and all these you have to check. Swapnil. Always look for the separator first. That's why I am giving you these links. When you open this URL link, you will see that your data is, what is the nature of the data. See, I have been guided to take the old old topics. The new will be for the new batches which will be coming in July. So you don't have to worry about the new updated topics. You have to look for the latest one. You have to look for the older one. So according to the old one, we are getting all fine. I think in the new one, lessons are been reduced even furthermore. Okay, but similar topics are there. Majority of the topics are same. That particular chapter is still updating itself. So don't look for the updated part. Whatever the older one is there, that will be followed for this batch. That is meant for the new batches, which will be, I think, in August or July end. Okay, so that's how it is. All right, everybody. So hopefully you have understood all these points that we discussed. PCA, it's better to be discussed with the machine learning part. So there is no need for that to be covered in the machine learning. How to take all Excel file from the folder using folder path. Use loop. You have to then see, first of all, read function doesn't work like that. You have to read one data at a time, and after you finish reading them one by one, then later you can join them. So you have to first read all the files with the help of the folder, okay, by the help of pandas.read function. So read each data one by one, and then join them or merge them to create your final data. To read Excel sheet, we have got read underscore Excel. I think I have discussed how to read the Excel as far as I remember. Read underscore Excel is there. pd.read underscore Excel. This is the function that we have to use to read the Excel data set. Okay, any more questions? Please ask. Go ahead. Keep on asking the questions. I'm not going to discuss anything new. I think that already the time is over. So I'll take only your doubts and questions. If you don't have any questions, feel free to drop. Thank you so much for joining today's lecture. Hopefully you have been benefited by all the materials. Roshan, I'm every day mailing them. So anything left in pandas? No. As far as data science was concerned, I've already surpassed the things which were there. Rest of the things you will be studying in your machine learning portion. Madhu Mohan. I have already given more than enough stuff. Notes are not received. I have, I think in the morning, at the beginning, we have already discussed it. That was somebody's question. Yes, I will be guiding you all for the final project as well. On the last day, that is next week. Should import all data from Panda or NumPy or both for data analysis? What is the meaning of that? Upmat, please write the questions properly. I'm still not able to understand the way you are taking your questions. I'm not able to understand it at all. Should for a given data set of data set, whether we should import data from PD or NP? What exactly you are talking about? Which type of data we are talking about here in this case? Quickly ask the question, please. Otherwise, we have to end the meeting. Should we submit the assignments in each chapter? I don't think so. It is important. There will be only one project that you have to necessarily submit it. Real-time KNN example. Whether it is KNN or if it is your logistic regression or if it is linear regression or if it is K-means. KNN or logistic regression. These are the two examples where where we will look for if my Y is a categorical data. One example could be, suppose I wanted to KNN part, right? So in this example, I think what type of data we have taken. This is a real world example. What are we trying to predict here? If a customer is gonna buy the product or not. This is a real time problem statements. Let's say we will be having a salad. Let's say Subway example is there. Let's say Subway. Replace this all data by Subway. And I wanted to check if the customer who are visiting to our stores, that is gonna be buying our product or not. Okay, and which type of items they are likely to buy. These type of classifications you can do it with the help of KNN or your logistic regression or any other algorithms which you will study in your machine learning part as you will proceed. Okay, so this could be related to that. Suppose at iPhone store, the store manager wanted to increase their revenue, and in order to do so, they can target the specific customers with the help of the machine learning algorithms. Okay, completed everybody? Any more questions? UPMTH. I'm sorry, I'm not understanding your questions. I'm again requesting you to post your question, but this time more clearly. If it is related to simple data, you don't have to download it. Only the project part you have to download necessarily on in priority. So if we have to start with our project 3, which data set are to be imported for pandas or numpy? Project 3. Okay, just give me some time. We will discuss it. Sorry, so Mr. Sudarshan, I am not allowed to share any personal contact details. So if you need any support, you just please contact the. You just raise a ticket, and the Simply Learn team will be contacting me, and that's how we can connect. All right, participants. I think there are no more questions there. So tomorrow's agenda will be really important and easy ones. Like we'll be targeting ourselves to discuss NLP part. So we'll discuss them. Thank you so much, everybody, for joining today's session. Please feel free to drop. And yes, do provide your valuable feedbacks after the session ends. You will be redirected to a external link. Follow that and give your valuable feedbacks. Thank you so much. Bye-bye, everybody. Good night. Take care. We'll meet you tomorrow. Materials, I have already shared it. So if you haven't received, please contact Simply Learn. From my side, every week I'm sending it. So if you are not receiving, please raise a ticket. They will definitely give you the support. And having said that, that's it. I'm ending the meeting now.